not. But no one reminded me to record. So there we go. First first hour of our day is gone. No, I'm joking. I'm joking. Usually the first 30, 45 minutes we'll spend talking about the assignments, but so we've only missed a little bit. All right, but in terms of how we create models for understanding data analysis, statistical analysis, any kind of estimation of means, outcomes, predictions, projections. Essentially, what we are doing is we are saying what our outcome is. We are creating some kind of model, and all a model is various pieces, right, that go together to basically come up with some sort of estimate. However, we have to understand that we are human and we make mistakes, right? So we will always have some form of error that we cannot account for. So, for example, we just looked at flight data last week, right? I believe several of you talked about number of cases going up and how that affects the number of flights. Also the demand, right? Certain types of airlines, right? Having higher demand than others. Certain places not having flights coming in and out, etc. We can include all of those factors into a model, right? All of those factors into one model. But guess what? We're still probably not going to account for everything. Because what if we cannot account for any kind of federal mandate for, masking, or any kind of state mandate? Well, by the way, I'm a state employee, right? I work for a public university system. My state dropped basically we cannot pay for any out-of-state travel during 2020. It all got taken away. Well, I don't remember hearing any of you say state restrictions on out-of-state travel, right? So guess what? Arkansas, if I was part of your sample, right, then you would have seen me fly 0 flights, right? Because my work would not have been able to reimburse me. That would have shown up in this error, on this error side, right? So remember, thinking about why people do what they do, and for example, what else happened because of the pandemic that we probably couldn't have predicted at that time? Does anybody want to think a little deeply? What happened as a result of the pandemic that you didn't see coming, besides the number of cases and the number of deaths? Let's just get that out there. What else happened kind of in society? Anything else?
Does this need to be flight related?
Oh, no, not flight related. No, not flight related. I'm talking like
just in general.
Give you one example. Are you ready? Yeah. What's that? Yeah, just in general.
The unemployment
Go ahead,
rate.
Rosanne. What's that?
I said the unemployment rate rose and inflation.
Unemployment rose, inflation also increased, right? Did you see that coming when you heard that there was a pandemic out there, or is that something that just really surprised you?
I wasn't that shocked.
Okay. Yeah, I wasn't, but I mean everyone is different. In fact, we're going to talk about that. Actually, we're going to talk about that example here in a minute. I'll give you one example, just one, and then I'll let y'all come up with your own. When the pandemic started to spread, I did not predict the decline in retail sales of business wear. The number of suits, I wear suits a lot. I just took off my coat when I got home. Suits like Joseph A. Bank, those sorts of places, they tanked. No one bought a suit. But what increased dramatically during 2020?
Casual.
Sweatpants.
Wait, what's that?
Sweatpants sales.
Sweatpants. Rottene, what'd you say?
Yeah, I said casual wear and maybe technology.
Casual. Yeah, casual wear. I mean, goodness gracious, like I was at home. I mean, honestly, I wore jeans for a year. It was fantastic. But yeah, so what else? Now think about that. Now take that a step further. What else happened as a result of the pandemic that you could not have predicted, or you did not predict on the front end, or did not think about or consider?
I was pleasantly surprised by the information about lower rates of pollution.
Ah, yeah. I've got another great podcast episode that talks about how whales are singing lower in the oceans. They are not, you know how whale sounds, right? Like, "Oh," I'm not gonna try to create that. But
Do it again.
because of what's that?
I said do it again.
No, but because there's not a lot of sea traffic, not a lot of cargo ships going through the routes that they're going, they are singing in lower tone, lower whatever the technical term is for it. But yeah, they are not having to sing. Birds are louder to us, or they were louder to me in parks and stuff, because we just didn't have traffic. Juliana, you had your hand raised. Juliana, you there?
Yeah, sorry, my connection just like went out a little bit. But one of the things that I could not have predicted was the shortage of baby formula and also the shortage of toilet paper.
Yep. Boom. Everybody, I mean, goodness gracious, we have about 30 rolls of toilet paper stashed away somewhere in this house. My wife won't tell me where it is. But yeah, shortages. And why didn't we see that coming? I mean, people weren't working, right? We should have thought like, oh, toilet paper doesn't just roll itself, right? But no, it's one of those things that I didn't see coming. I still cannot find undershirts, like white undershirts for me. Still can't find them. I'll give you one more, and then we'll move on. Again, kind of a pleasant surprise, but also now I'm a little bit concerned about it, because NPR just reported this morning or yesterday morning that because more and more people are going back to work, their newly adopted puppies or kittens are not transitioning well because they were with their owners 24/7, 365, and you know, it's just kind of like, it was great to hear on the front end, but now I'm like, oh my gosh, my little buddy he was loving it because he stayed right here under my desk all day. But nonetheless, we can't predict everything, right? Next pandemic, I don't know what's going to be the next toilet paper, but there will be something, right? So let's understand on the front end that we are not perfect, right? There's always going to be error. So what we're really trying to do is create models and measure how well our values fit within them. How well our values fit within them. If, let's just say, thinking about the average, right? If the heights of all of us, the average height of this class is, let's just say 5'9". Well, you know, does that mean we have a lot of variation? Does that mean we have very little variation? Are we all really just 5'8" to 5'10", or are we 5'1" to 5, or 6'7", or something like that? Essentially, what we're looking at here is measuring fit by looking at what we call variance, or the mean squared error. Really taking into account the error, the changes from each of the individual heights of people in this class up against the average height. How much variation is there from one to the other? So what we're really thinking about here, and this is probably a term that most of you have heard in your lifetimes, is standard deviation. The average deviation that's been standardized between all of the individuals in a sample and the actual mean, right? The mean of that sample. So standard deviation represents our samples. When we're talking about, remember how we talked about earlier about populations? Sometimes we do have population studies. I deal with population studies all the time. And the reason why is because I have all of my students. I have all of my faculty. You can't get hired at one of my institutions and me not know how much you make, right? You can't get hired at one of my institutions and me not know what your birth date is, or what kind of contract you're on. I mean, it's just the nature of the work that I do. So I work within populations a lot. So when we say standard error is related back to populations. Standard deviation is related back to samples. Okay, but both of them are looking at how well the averages fit within that group that we're looking at. And so one of the ways that we talk about fit specifically within data analysis is by calculating what we call confidence intervals. Because again, we know we're going to have error in our measurements, okay? And so because we know we're going to have error, essentially what we try to figure out is what is the range around the average that we feel confident the true value will fall within, okay? So normally we talk about 95% confidence intervals, right? 95% confidence intervals. So that essentially means within 5% either way. So if we were looking at the average income of all Americans, and we found that based on the data we had, maybe using the census, right? The average income was $55,000. Well, what we can do is take the standard deviation. When we calculate a standard deviation, we can then multiply that times 1.96, which is, essentially the measurement for a confidence interval at 95%, and then subtract it from the mean. And so what if that 1.96 times our standard deviation was $5,000? 1.96 times standard deviation, we're just making it up. What if it was $5,000? Well, our lower bound, if our average was 55,000, our lower bound would be $50,000, right? Minus 5,000. But our upper bound for the 5% confidence interval would be 60,000. And so essentially what we're saying is the average income of individuals in our study was $55,000 plus or minus $5,000. It's essentially, we're saying that the true value is 95% likely to be between $50,000 and $60,000. The true value, we have a 95% confidence in the data that we have that the true value of the population is somewhere between $60,000 and $50,000. Does that make sense, y'all? And you see confidence intervals quite a bit. Has anyone ever actually gone out and downloaded census data? Okay. If you haven't, that's okay. I mean, I'm not telling you have to, but they do use confidence intervals for all of their estimates within what they call the American Community Survey. This is a sample distribution that they do usually within larger metropolitan areas every year. And they use confidence intervals because it really helps you understand, like, okay, because we don't report our income to the census every 10 years. I don't know if y'all noticed that or not, but when you filled out the little online survey, you reported how many people are living in your household, right? You reported probably the ages of those people, I think, living in your household. and I think maybe one or two other things. It's actually pretty short. Where we get data about, oh, and also race ethnicity. I'm sure that's part of it. Where we get information about full-time employment, other employment, how long it takes for you to drive to work, what's your income, all that kind of stuff. That's actually from the American Community Survey. And so they do a lot of sampling to get a representative sample of the US or of the state. But they use confidence intervals to show you that if you're looking at the data, if your standard deviation and 95% confidence intervals are really high, that should give you fair warning. Like, you're probably not too confident that the average income in Georgia is $55,000. If the 95% confidence interval was 20 grand, that means, well, we're 95% confident it's between $35,000 and $75,000. That's a lot of wiggle room, right? That's not. I don't like that as a statistician. I like for my confidence intervals to be pretty short. So when we look at confidence intervals, we are essentially doing the calculation that's listed right up here, top left corner of the screen. We're taking the average value, we're getting the z-score, which is 1.96 for a 95% confidence interval, and we're multiplying it by the standard deviation, and then we're dividing it by the square root of the number of whatever, right? The number of people in our study, the number of airline companies in our study, right? It's whatever our unit of analysis is, right? And so what you need to know to do all of this right here are a couple of different functions, right? A couple of different Excel functions. So average, right, is pretty straightforward. Standard deviation for a sample, STDVA. Count is where this n comes in. And then square root, right? And square root. And then, of course, mathematics, which is plus, minus, multiply, divide. Does anybody have any questions about that part of it? Has anybody played with all of these functions already? And hello to Laura Best Cat. She made an appearance. And so did Kara's dog. You just scared him away. Has anyone already used these functions in your analysis, your work, anything like that? Okay. So in that case, go ahead, Rotene.
I was gonna say no. Can you click back on it?
Yeah.
All right. Thank you.
Yeah, no problem. And remember, these slides will be posted out there on the web for you too.
Okay.
What's that?
I said I just wanted to write it down, but I have it. Thank you.
Oh, good deal. So let's take a break. How's 10 minutes sound? Sound good? Top of the hour? Okay. See y'all in a minute. All right, welcome back. All right, so in order to better understand confidence intervals, I figured we'll use some sample data this time, and we're going to move into my realm a little bit for the end class. We're going to get into higher ed. Last time, of course, we used flights for the assignment. I believe I looked at COVID. COVID for the in-class demo that you saw recorded. I really will try to change up the type of data we look at to make it more relevant, but also give you a little bit of examples and experience across all these different types of sectors. So remember before, when we were talking about how to calculate confidence intervals in Excel, I said you need about 4 different functions here, right? Average, standard deviation, count, square root, and then all the math that goes behind it. So here I've got our sample data set, and this is completely fake student IDs, just so you know. But these are actual student high school GPAs within my system at 2 institutions. So institution 1 looks like it's got, goodness gracious, there's a lot of students in institution 1. There we go. Institution 1 has somewhere around 1,000 or so, 1,057 students. Institution 2 has 469. So these are straight out of high school coming into our institution. We often look at high school GPA as a good predictor of success, retention, all these other things, right? So first thing I always want to know is, well, what's the average and what's the confidence interval for all of our different institutions? So pretty easy to do. You saw us do it before. Equal, well, that's not the right way to do it. Equal average, sorry, I say the word mean. Equal average, and then I want the average only for institution 1, right? So I can just click and highlight and drag all the way down to 1,000 or something. There it is, 1,010.58 is the row. And then hit enter. And it's 3.61, right? Same thing with STD-EVA, standard deviation. I just want to click and drag all the way down to 1057 or 1058. And so right away, within 20 seconds, we've got our average high school GPA for this institution is a 3.61. Standard deviation is 0.41, right? So within one standard deviation either way, it can fluctuate from 3.2 all the way up to 4.0 pretty much. That tells you something, right? 4.0 is the top of the GPA ladder. So yeah, that's pretty close to being 4.0. Now the count is just equal count. That's all. Equal count, and we can count anything. We can count the ID. We can count institution 1. We can count the GPA. Doesn't matter. Just make sure we count it only for that institution. All right. So yeah. There we go. It has to be a number, apparently. It doesn't count things that are set up as text. So nonetheless, let's try that again, actually. I just want to test something. Yeah, okay, weird. 1057 is our count. So we know our confidence, because we're doing a 95% confidence interval, we know that's 1.96. That is the value of a 95% confidence interval is 1.96. That's just straight fact, no formula necessary, right? Now, to get the confidence interval, does anybody remember the equation that we have to do? Laura Beth, we just talked about this.
I was shaking my head no.
I wrote it down. I can try and I'll try.
No, I'm just messing with y'all. I'm just messing with y'all. It's okay. So basically, it's the mean, the average, plus or minus standard deviation times the z-score divided by the square root of the count, right? So it's a little complicated, but let's start with the equal sign and z-score times standard deviation, right? Z-score is 1.96 times standard deviation, right? Close the parentheses and then divide it by the square root of the count. So here we're going to open a new parentheses, and the square root function is sqrt. Open that parentheses, put in 1057, close the parentheses, close it again, and there's our confidence interval, 0.025. So what that means now that we have our confidence interval is we want to calculate the upper and lowers, right? We want to know what that range is. So to count the upper, we add the confidence interval to the average. So we take the average and we add the margin of error to it. To get the lower, we take the average and we subtract the confidence interval from it. So our confidence interval, written out whole, is the average GPA from institution 1 is 3.61 plus or minus 0.025, which you can also write out as 3.64 to 3.59, right? Or 3.59 to 3.64. So that's one way of doing it. Let's look at a different way. Let's look at a different way. Remember how before I said,
I have a question in regards to the confident intervals. On the lower, you stated in one of the slides, it equals the mean times 1.96 and the standard deviation. And for the lower, and the upper is the mean added to 1.96 and times the standard deviation. Is that always going to be the formula? Like the upper is going to be positive and the lower is going to be negative?
Well, no, it's more like the upper is the confidence interval number that's calculated here plus the mean, and the lower is the mean minus the lower the confidence interval itself. So the way we do this, Rodney, is we always add the confidence interval to the average to get the upper, and we always subtract the confidence interval from the average to get the lower. Does that make sense?
Okay. Yes, it does. I was just making sure.
Cool. No, it's good. Good question. So remember earlier we talked about the if function and how it can make your life a little bit easier, even though the example I had was just, we didn't have time to go through all of it. There are other types of if functions in Excel that are really handy. So if by itself, you have to talk about the logical test, the value if it's true, the value if it's false. But you can also sum if, which means add something together if something else is true. Or you can do an average if. So you can average something if something else is true. What you first have to define is the range that you're going to look at. Like what are we really trying to isolate here? Are we trying to isolate by institution? I think we are, right? Institution 1 versus institution 2. So we select column A, type a comma. Our criteria is quote, inst 2, end quote. And then the range that we want to actually average, we don't have to click and drag anything. We just click on column C. Just click on column C. Where institution 2 shows up, those are the fields that Excel is going to average. And it says that the average GPA for institution 2 is a 3.42. Just to Right, Kara, go ahead.
Where it says A:(A) and C:(C), does that mean that if we add values to the bottom of those columns, the average will automatically update?
Yes.
Okay,
Yes,
thanks.
that is calculating average for the entire column. So what did we say it was, right? 3.42, right? What if I have an 80 GPA? It raises it to a 3.59. Make sense? No, it's a great question. Yeah. Yep, so that's a live field there, right? So if you mess with anything, there is no standard deviation if that I've found. So unfortunately, we still have to do the manual standard deviation for institution 2. And so just come down, click it, drag it. There you go. And if you just want to double check, we can easily do an average if over here it was 3.61, right? Average if, column A, comma, inst 1, comma, column C, 3.61. Pretty cool, huh? Count has a count if also. So instead of doing count and clicking and dragging, we can say count if that is institution 2, 469. All right, so again, so just want to show you both ways, right? Some people feel very comfortable one way, some people feel very comfortable the other way. Do it, feels most comfortable to you. Now, the confidence interval for this one, all we have to do, we don't have to type out everything. Remember how we had to type all of the F6 times F4 divided by the square root of F5? Excel allows you to drag formulas and it moves the formula with you. So do you see how when I hover over the cell, it's like a wider, like white cross? When I hover over the edge, it turns into the arrow cross, which allows me to move it if I wanted to. If I come down to the bottom right, though, this is what we call the crosshair. You see how it got really small? If you click that and drag it over to the right, it moves the entire formula. And now it calculates the G column, G6 times G4 divided by the square root of G5. So now, without having to redo that work and possibly mess up, Excel has allowed us to calculate our confidence interval for institution 2. And also, we can select both of the formulas for upper and lower bound and move them over. And it does the same thing for institution 2. So one of the things I like to tell people, when you're working in Excel, do everything, probably have to do everything one time, but after that, you can, as long as you keep everything organized, and I'm a little obsessed with myself, then you can really save yourself some time. Does that make sense, everybody? Cool. Okay. So now that we've got our, our data figured out here, now we may want to learn how to visualize this sort of thing. So what we want to do is really kind of think about the different types of visualization. And mostly when we talk about confidence intervals, we look at them in regards to overlapping bars or overlapping error bars. This is a simple Excel chart. I'll show you how to make it in just a second. But essentially, the average GPA at institution 1 is 3.61. Average GPA for institution 2 was 3.42. What we need to know, though, is we need to incorporate our confidence interval, right? Our 95% confidence interval that is made up through this bar, right? These are called error bars. And if these bars do not overlap, if they do like this, right? If there's a gap between them, then we can say that these two populations or these two samples are different. They are different, statistically different. This is, you may have heard people talk about alpha values of 0.05 being statistically different when you look at, studies and all this other stuff. That's essentially what we are doing right here, right now. We are looking at the confidence interval between these two sample means, and essentially do their confidence intervals overlap. And when they don't overlap, we can say that the average GPA at one institution is statistically significant. There's a statistically significant difference between it and another institution. So let me show you how to do this real quick. Let me make sure I've got the right one up. Okay. Let's go to insert, and Kara, I'll let you critique my labels, okay? So if I want to insert a bar chart, well, we can do it a couple of ways. We can just select the cells right here, right? Go to insert and then select bar chart. There it is. Pretty easy, right? I hate the automatic axis, so we will format that to be a 0 minimum, make it a little bit more realistic, but it may be harder to see the differences. So we can bring it back down just so you can see the difference. And so I like to also color code. Notice how when I click in, both of them are selected. So I click one just to change the color of one. And then I'll click the other just by itself to change the color for it. Now, what we want to do though is we want to add our confidence intervals, right? You may think like, oh my gosh, I have to go in and click a bunch of things, but really you don't. Under design, you can add a chart element, and there's a selection called error bars. And under more error bar options, you can do, there it is, yep. So both directions, you want to do both directions, right? Because you're talking about upper and lower. And I always put a cap on it so you can see it a little bit better. And then the fixed value is 0.05. So that 0.05 is what we want to keep, right? And we're not trying to do the standard deviation or the standard error. We are trying just to do the 0.05 error, right? The error values, otherwise known as confidence intervals, right? Margin of error. Now, I don't know how easily you can see that. So under format, I typically come down to the weight and make them a little bit bigger. Does everybody see that? So similarly to our PowerPoint, right? Here I did 3.0 to 3.8. We can do that too, just to keep it consistent. There we go. So you can easily see that the 95% confidence intervals do not overlap between these two institutions, right? They do not overlap. However, confidence intervals are a function of the size of your population. They are a function of the size of your population, because remember, the formula itself is divided by the square root of the count, right? So let's take both of those. We'll paste the formulas. There we go, and there we go. And just to keep them the same, right? Bring down the decimals, and or keep it, we'll just keep it all pretty much the same. Except I'm going to change the number of people in the population. What if we cut the population down by about, to only 10%? What, instead of 1057, what if we only had 106 students? And then for 469, what if we only had 47 students? So what if we reduce the size of our population, right? Then what we would have is very different upper and lower bounds. We would have very different upper and lower bounds. And note, you can actually see this you can visually see it just in the data. You can see that the lower bound of institution 1 overlaps with the upper bound of institution 2. So if we create a new table, and instead of plotting that data, we plotted this data, right? Then we would also expect to see the, basically the bars would shift. The bars would shift if we were able to, plot everything out. It's one of the things that we really need to think about. How do we visually, there we go, how do we visually know if one sample is different from another? When we reduce the number of people in a sample, it can have an extreme effect on whether or not we can estimate that the two populations are different. And so I tell you all this tonight, and I know this is a lot to take in, but determining whether or not one group is different from another group is about half of the work that we do in statistical analysis. For example, do females graduate at higher rates than males, right? Generally, yeah. We know that to be pretty true across higher ed. Are 16-year-olds more likely to get into car wrecks than 26-year-olds, right? We're trying to determine whether or not there is a difference between two or more groups, right? What about your work? What about the work that you do? When do you wonder about differences between groups?
My work is not very sociologically hard hitting, but we look at the statistics of whether homes that are staged sell at a significantly faster rate than homes that are not staged. And so that would be a population difference that we would try and sort out.
Yep.
Do they?
Kara, I don't know if I told you this. Oh.
They do actually.
Why is
And when
that?
you
Do
say-
you know? Oh, sorry.
No.
No.
I was just going to say, when you say staged, do you mean professionally staged, or do you mean like someone's living in the home, but at least they go through and they clean up the laundry?
Oh no, professionally staged. Yeah, and the reason, just real quick, Rajane, is that it you remove all of everybody's personal stuff from a house, and it makes it easier for the homeowners or for the buyers to imagine themselves in the environment.
It's almost like a blank slate.
Yeah.
Now, I will tell y'all, when I moved here for this job, we bought our house. It was a brand new home that was just built. We were in it for 6 months, and we had it on the market for less than 1 day. And this was pre-COVID, of course, and it got an offer for the asking price. We didn't have it staged. We had pictures of ourselves all over the place. We don't know if people who bought it liked it or liked our dog, but I'm just here to disagree with whatever y'all say. No, I'm joking. But no, yeah, that is something that so homes that are staged versus homes that are not staged, that is more of a statistical analysis than you might even think, Kara, but definitely a good example. Definitely a good example. Right now in the market, I mean, I hear it's hotter than Hades. I don't know if that analysis would hold up now, because people just don't have homes to buy, right? Yeah, good example though. Go ahead, Ken.
Yeah, I have a question. So how do we add the title and the XY label?
Oh, into the chart
Yeah,
right here. Yeah, I'll show you real quick. I'll zoom in
thank
a
you.
little bit. Oh, yeah, under design, again, we can add more chart elements like the titles. We can do a chart title. I usually do it above the chart. And this is average high school GPA, right? And then for
Eric,
the
watch out.
Nick,
label,
your screen's
Oh.
like froze or something.
oh, I'm sorry.
Yeah,
Is
okay.
it better now?
Yes, thank you.
Sorry about that. So I'm sorry. Here, I'll undo. There. All right. So under design, the design menu, you can only get to it if you've clicked on the chart, by the way. If you click off the chart, it disappears. So click on the chart, design, add chart element, chart title. And like I said, I always do it above the chart. And I just do average high school GPA. Hit enter, boom, there it is. For other labels, if you want to do them, like the axis titles, you can do a primary horizontal, and just call that institution, and the vertical one, you can call that high school GPA. But yeah, there are a lot of things in the chart element. And really, I mean, not now, but later, I'll show you how to incorporate trend lines that can help with forecasting. I try not to mess too much with legends or grid lines unless I really need to. But if you wanted to add data labels, for this one, because we've got our error bars, I would not put them necessarily on the outside end because they would be overlapping with the error. I would put them on the inside base and change the font to something like white. That's easily visible there. Does that make sense, y'all? Cool. Sean, Ken, does that help?
Yes, thank you very much.
Cool. Yeah, no problem. No problem. So going back to the idea of what types of groups are we comparing, Kara gives you an example, homes that are staged versus not staged. What are some others? What are some others? Does anybody here drink coffee?
All day.
Okay. Yeah. If it's colder outside, do you drink it all day and all night, Lord Beth?
And all night?
Mm-hmm.
Yeah, I would say when it's colder, it's definitely a night drink more often too. Yeah.
So looking at groups of people that live in colder climates versus more temperate climates, cost consumption might differ, right? There might be differences in those groups. Ratane, what do you like to do when you're not on a Zoom class?
Exercise, cook,
Okay.
listen to music, go on adventures, watch movies, different things, work on my business.
Goodness gracious.
Yeah, I like
Stay
to
busy.
try to stay busy.
Yeah. Well, let's think about music then. What about music? Are you in the exercise group that listens to music? Let me say this, exercising group that does not listen to music when they exercise, listens to music at a lower beats per minute, or listens to music at very high beats per minute when you exercise? Which one are you in?
High beats. It gets me in the mood and energized, like pumped up.
Yeah, me too. I listen to a lot of electronic dance music and techno, dubstep, all that stuff too. But nonetheless, what we find is that I read a study a while back, and those three groups people with the high intensity music when they exercise actually have a higher resting pulse rate, even if they run just as far or exercise just as long. People who listen to lower beats per minute have a lower resting pulse than even those that don't listen to music at all. So 3 groups, different outcomes, right?
I agree. It depends on my mood.
Yeah, I just gave blood. There's a big shortage down here with Hurricane Ida coming through, and I was eligible to give. So I gave double red blood cell count, and they always give you like your your diagnostics, and my resting pulse rate was 58 that day. So I was like, I need to up my beats per minute. Ken, what do you like to do when you're not studying?
Watching movies, listen to music. Yeah. Mm-hmm.
What kind of movies do you like to watch?
What kind of movie?
Mm-hmm.
Crime, horror. Yeah.
Has
So let
anybody
me ask
seen
you this.
Clickbait? Even though it's not a movie, but it's a show.
Yeah, I saw it on the menu for Netflix, I think, right? But I haven't watched it.
It's pretty
Scary.
good. I'm not gonna lie.
My spouse does not watch scary things, so neither
Check
do
it
I.
out with your wife. It's not too scary. It's a suspense show. It's nice.
She might be calling you later if it is scary.
I know she might be side-eyeing you, but she gonna like it.
Yeah. Well, Ken, I've seen studies where they have analyzed sleeping patterns for people who watch scary movies versus like rom-coms and stuff like that. And what do you think? What do you think happens? What do you think the outcomes of that comparison of 2 groups is?
I don't know, but I remember before in high school, if I have a big test tomorrow, I will watch a horror movie before I sleep. I don't know why, but make me sleep.
Okay.
Yeah.
That's exactly it. People who enjoy scary movies actually sleep better after they watch one for some reason. So it's funny that you watch them before a big test. It's almost like you're just trying to get the fear out, right? Get the fear of a bad grade or something like that out. I don't know. That's cool. That's cool. Juliana, what about you?
Like to do now consists of being able to get all of my laundry done in one day. So, but pre-baby, I like to paint my nails, go shopping, cook, organize things. So yeah.
That's awesome. So you now with the newborn, right? Would you say your consumer spending habits have shifted?
Most definitely they have. On my day comparing, well, now whole milk since he's going to be 1 on Saturday, but he I was wondering what that was. I couldn't tell if it was a milkshake or just milk.
I drink about a gallon every day.
But comparing like prices of baby clothes and having that expense in our budget and things like that, because he's already in 24-month clothes and he's only 12 months old, so
Yeah, so think about it. Think about those 2 groups, right? Pre-birth and then postnatal. Spending habits. I don't know if this is y'all's first, but first time parents and how that changes. What I'm trying to get you to do is to think about how we can compare outcomes of groups and how those outcomes can be measured or analyzed in certain ways, understanding the fact that, going back to the very beginning of this lecture, that we're always going to have error that we cannot account for. Juliana, I don't know if you've looked at it or not, but baby wipes have kind of flown off the shelf almost as much as toilet paper because they are, you know, what people are using to like clean stuff often, you know, disinfectant wipes, all of that. I'm sure you probably had a better chance of getting those pre-pandemic than you do now. Have you had any troubles with it?
Not now, because my husband is lucky enough to where we can, you know, go to Sam's Club or Costco and buy in bulk. And also our baby shower, we're still using wipes from when we had a baby shower, 14 months ago or so. So we haven't had to buy much with that, but I am noticing, like, when I do go in the store and just to look and see, there's not a lot of options. And what our options are, like the scented wipes and the wipes that like parents don't want to use on their kids because they're either using like the sensitive skin ones or like the fragrance free. So it's the ones filled with all the chemicals and stuff.
Yeah. Pretty soon, the only option is going to be sandpaper. So just get ready. I'm just joking. Hopefully not. So what I also want y'all to think about in this thought process is, what are some of the ways that we think about specific outcomes, right? What are our hypotheses? What are the predictions that we're making of some sort of an outcome or some sort of effect of an outcome? So a null hypothesis, you're going to be reading about these in some articles. Null hypotheses are essentially what we say is that any kind of absence of an effect in a study. So if my study, going back to one of your examples, right, consumer spending habits of new parents, what if I said that new parents for the first time spent money exactly the same way they did prior to the baby's birth? I think we would all laugh and shake our heads and be like, heck no, Eric. But that's what we mean by stating a null hypothesis. That allows us to essentially focus in on what we mean by our study, what we're actually trying. Yeah, it's not realistic at all. But what are we really trying to get at, right? I want to be able to reject the null hypothesis. I want to be able to say there is an effect of a newborn being brought into this world on our spending habits, right? So we either reject the null hypothesis, right? Or we fail to reject the null hypothesis. This is more the scholarly type of explanation. So when the next assignment that you have where it talks about, you know, how do you explain it to, you know, your sister, your mom, your dad, whatever. Well, you don't tell them that we failed to reject the null hypothesis. That's more of a scholarly type of approach. What you can tell your family is that we didn't have enough evidence of any kind of effect or impact on something. But just again, trying to get your mind thinking about it. So going back to this idea of error, right? We talked about error earlier. It's going to be present in everything. One of the initial studies that I saw talked about looking at all the job losses that occurred in the pandemic. So, Ratane, remember you talked about this earlier. We found, not we, me, but people who were doing this study, they found that there was an extreme amount of job losses as a result of the pandemic. What they found in that analysis, though, is that the study itself was overrepresented in the certain locales, states, cities, counties. They were overrepresenting the number of retail business owners or business workers and restaurants. So while there were job losses in the pandemic, when you only ask people who work in businesses that were closed to respond to the survey, it's going to make it look like, when you extrapolate that sample to the broader population, it's going to make it look like there's a much larger effect that's not really there. It's not really there. So what we do is we call this type 1 error. Type 1. when we say there is some sort of an effect in the analysis, but there may not be as great of an effect or any effect, okay? So type 1 error. Type 2 error is the exact opposite. We say that there is no effect, but there is. So we make the assumption that there is no effect within our analysis, but in fact there is. So on the flip side, what if in our sample it was overrepresented by service workers who did not see impact, really job losses at the same rates as maybe retail and restaurant workers? I'll be honest with you all. So I received the Paycheck Protection Program loan from the Small Business Administration to support the small business that I own. Well, that, helped out a lot, but you know who didn't blink an eye during the pandemic? My accountant. My accountant, even though tax filings got delayed, they got busier because not only did they have everybody's tax documents and everything, but the Small Business Administration, the Treasury were doling out funds in these PPP loans. So actually they got busier and the demand for accountants got bigger. Education, I work in education, not one iota of my out of my boss's mouth was ever about anyone being laid off or being let go. All of our institutions and all of our K-12 schools retained every employee that they could. And the reason why is because our governor actually made that a priority. He said, do everything you can to hold on to your employees, right? So in Arkansas, at least, I don't want to speak for everybody, but if we were sampled, right, if the broad population of service workers, education, accountants were sampled, well, then you might think that job losses were actually minimal in the pandemic. And so this, again, is a type 2 error. We know that job losses were staggering in some cases, but they may have been minimized depending on who you sample. Does that make sense, y'all? Okay. Laura Beth, you said sounds nice. What did I say? It sounds nice. Sorry, I just kind of went on a rant.
A state government that was concerned about teacher retention. Sounds nice. It was just sarcastic.
No, I agree. Teacher retention, K-12 teacher retention is already so difficult. That was one reason why they really put an effort into not letting anyone go because of state revenue declines or anything like that. Because we knew if we lost the teacher, it would be very hard to get them back. We're a rural state for sure. All right, so taking all that into consideration, this week you're only going to have one assignment. You're not going to have a discussion and a lab. You're just going to have a lab assignment. But I'm going to be honest with you. This is messy. This is not flight data. You're not in Kansas anymore. Okay. In fact, I've got the data file pulled up here. It has column A through column AK, so that's 37 columns, and 140,825 rows. Okay, not just one row for each day of the year. This is big data. Big data in terms, I mean, not like big data. This is decently big data. What this is, I put a link to it in the chat just so you can see where I got it from. This is Federal Election Commission donation data. So we are looking at actual political contribution donors within the state of Georgia. In fact, within only two cities. Those two cities are Augusta and Columbus. I thought about including Atlanta, but then the spreadsheet would be in the millions probably.
Eric?
So, yeah.
Do you want us to we're not seeing the spreadsheet. I didn't know if you
I,
wanted us to be
sorry,
seeing it.
my processor, I think, is running a little behind. Do y'all see it now? Okay, sorry about that. So yeah, so you haven't missed anything. I wasn't showing anything crazy. I was just showing you the 37 columns, all 140,000 plus rows. It's a lot of data. There's a lot of data here. But let me put your mind at ease a little bit. You're not going to be analyzing every column. Remember in our first assignment, you analyzed, you analyzed 2019, 2020, and 2021. Those were the only real data you could analyze. You can analyze any and all of this. You might actually know some people in this data set. You never know. Well, Carrie, you might not. But you know, I don't know if I do. I haven't actually gone through and looked at it. But this is real data. This is real. This is not made up. You have the ability to look for it, look through it. What I want you to do is first take some time and look at the data set as a whole, right? Take a look at each column header and understand what it is, right? What it is. So here we have the committee idea, committee name, right? You're going to see a lot of different super PACs, People First Future, Biden for President, even individual Senate candidates. All of this is in here. So it's a ton of data. Then what I want you to know is really looking at the type of donation. Is it an individual donation? Is it a corporate donation? You know, you've got the individual's names, all of that. You can see where they're from, right? The city. That's the most important thing to recognize, because I am asking you to compare the two cities, right? So it's kind of like a tale of two cities in terms of political donations. It has a zip code. Whether or not it's earmarked, that's not a complete file by any means, as you can see. The contributor occupation, right? So it's actually super detailed. You can find out how many people are attorneys that are donating, how many people are artists are donating, how many people are retired that are just giving away money. Contribution amounts, right? You can look at individual contribution amounts or their aggregate year to date, depending on the assignment, right? There's going to be a lot of blank columns here, but not all the rows are blank there. You can see what type of election it is. I mean, y'all, when I say you have a wealth of public data out there, this is just one example. And again, this is just 2 cities in Georgia that we're looking at. So these are the questions that you're going to be focusing on. You're going to be looking at using Excel functions that we talked about to basically report confidence intervals. I provided you with the exact name of the field. So contribution receipt amount, we were just there. It's the first one, AJ. And the reason why is because I want to see what the confidence interval and average actual donation. This is aggregate over time, right? So this person donated $500, but then they also donated $7.76 at some point. So individual donation amounts is what I want you to look at. So then you will also look at the different types of elections. So calculating the average 95% standard deviation for the individual donation by the type of election, whether it was the primary election, the general election, the runoff and recount, all of those, right? Oops. And then you can do, I want you to also do this in the Excel data analysis toolpack. I want you to learn how to use the toolpack for it, and then plotting it in a chart with error bars, right? So you're going to plot the separate means for each city, and then you're going to plot the separate means for each election type. So you're going to do 2 charts, and then you're going to get into the fun part where you have to describe your findings as if you're presenting them to people who care, your worker, your coworkers, your boss, and people who may not care. In fact, my dad had a rule: no politics at the kitchen table. I'm about to just blow that rule right out of your house. Okay. If you have any trouble with this data file, please don't hesitate to ask. It is a lot of information, but you may notice I've only referenced 1, 2 columns, really. I mean, a few columns, but definitely not all 37. But I highly recommend take a look at it and just see what else you might want to do, because next week this is what we're going to talk about. But I'd love to hear your ideas of how else to use this type of data. Okay. It does, and I'll go ahead and prove to you the frustration you might experience. I'm going to start counting. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right at 19 seconds. It took just to open the file, okay? 19 seconds. If you're using a Porto to do this, make sure, doing it in Excel, just be patient, right? But just know that you're dealing with one of the bigger files. Actually, it's the biggest file you're going to use for any homework assignment. You may choose in your project presentation to use a big data file, completely up to you. But this is going to be the biggest one that I'll send you. Okay. Everybody excited about election donations? Does anybody have any questions?
When is this assignment due?
It's going to be due next Tuesday.
Okay.
I have a question about the overlapping confidence interval bars.
Yeah.
So if they don't overlap, that means we can't draw a relevant statistical comparison, or is that?
No, if they don't overlap, right, like this one, they
Yeah.
don't overlap, right? That means that we are 95% confident that they are different. If the bars do overlap, I'm pointing at my screen like you can see it. If the bars do overlap, like they do right here, it means that we cannot be confident we can't have 95% confidence that they are different, because they may not be different. The true value could be right in this section where the overlap occurs, right?
Got it. Yeah. Okay, thanks.
And so yeah, no problem. Sorry, I'll usually have to explain that 3 or 4 times. So don't worry about asking multiple times for me to say things differently. But yeah, here, I mean, we are sure at the 95% confidence level that this population of students is different from this population of students based on their high school GPA.
Yeah, okay. Thank you.
Cool. You're very welcome. Any questions about anything we talked about tonight or the homework assignment? Okay. Before I end, just a reminder, please take a few minutes, provide some feedback for me. I'd appreciate it very much. I'm going to stick around, so hop off whenever you're ready. I hope everybody has a good night and a good weekend. Thank you all for your great participation tonight. It's great to have these kind of conversations with y'all. Feel free, if you want to stick around and ask any questions, I'll be right here. All right. Kara.
I have a question. And I looked it up.
No, yeah, you're good.
Um,
Yeah. Oh, and by the way, feel free if you ever give her, and I should have said this before I jumped off. If anyone ever wants to stick around, like, and they know it at the very beginning of class, like, I want to ask you something after class, just put it in the chat box.
Oh, okay.
That way I'll know.
Okay, we'll do.
What's up?
I looked this up and I somehow am not retaining the information, but in his textbook, there, you know how he does the little pop outs, Jane Superbrain and Who's He What's It and the other. Yeah.
Jane
So on-
Superbrain is the worst.
I
mean, she's good, but like it's one of the those get a little too in the weeds sometimes.
Yes.
Go ahead.
Well, I mean, I still need to spend some more time with kurtosis. That's what we're calling it, right? But on one of them, it talks about how distributions can look platykurtic or leptokurtic, but not actually be platykurtic and I wrote down and have a post-it why, how. How does it look that way, but it's not that way?
Okay. If a distribution is, remember how we talked a little bit earlier? I'm trying to get my stuff. I'm not sharing. There we go. Okay. Remember how we talked about earlier about how sample size can affect things?
Yes.
Right? Coming back to that, there it is. Yeah, sample size can also affect how distributions appear. A smaller sample size can appear to be leptokurtic, but actually be pretty smooth. Only the fact that all the values are a little bit closer to each other, and you might have one or two that create the tails, actually make it look skewed when it's actually not truly skewed. The average and the standard deviation might be pretty normal.
Okay.
But having a few of those tails on the ends actually make it look much tighter in the middle than it truly is. And that's leptokurtic. You know what platykurtic is, right? Where it's more of the hump.
I'm still getting it. Some of these are intuitively backwards in my brain. So I have to constantly
So, yep. The easiest way to think about it, platykurtic is like a plateau.
Plateau. Okay.
Plateau. Leptokurtic, and this is how I explain it to my dog. That should be the next assignment. Don't explain to your family and friends. Explain to your dog.
Yes.
But leptokurtic is where you have to leap over it because it's so spiky. It's so sharp, right?
Yeah.
Makes sense. Sorry, I just tried to log in and it says I've been logged out. Sorry, I was trying to pull it up for you. But if that makes sense.
Okay, yeah. So it's just, well, the sample size explanation was helpful. So if your sample size is smaller, it's going to visually look like something that it might not be.
Right.
Okay.
Right. So, okay, what else?
That was my main, that was the one that just kept sort of rolling around in the back of my brain. So for now, that's it.
Okay, great. So again, tried to give you all a heads. Last year, I did not give them that much of a heads up on this data file, and I got a lot of hateful remarks. No, I didn't get hateful, but they were like, "Holy crap!" So just be aware. There's a lot going on here.
No, I'm excited about this. They at one of my 2 jobs ago, they called me the ninja shrimp because they used to joke that I was like a mantis shrimp, but I like to go into files and clean up all the data and organize it and make it pretty. So I'm down with the big Excel file. Yeah.
No, go for it. Have fun. And in fact, know it's there and know it's available for much more than Georgia. I mean, that's the other thing that, like, it's federal. So
yeah,
if you want to play around with it, please do.
Will do. Thank you.
Cool. All right. Thank you. Have a good night.
Thanks, you too.
Bye.
Bye.